All right, so now we want to not just remove the first item, we want to remove a random item from inside of here. It's actually not hard. I just kind of wanted to cut it off to let you do the simple stuff and get the simple stuff working, get the test case working before we moved on to the next thing. But here I can remove any item from the list here. If you haven't used it before, Java has, I'm going to create it as a variable in this case. Java has a class called random. We call it R because it's nice. Control space java.util.random R is equal to new random. So when I build the random, I can just let it build itself, or I can provide some external seed, which will make it slightly more random. Sorry, I'm doing this in real time. I sneezed. So Java, all computers use pseudo-random numbers, and the seed allows you to get slightly more random by providing a different thing than another time. So anyway, you'll cover that at some point in your studies probably as well. All right, so the random, I can say next int inside of random. I can say next a bunch of times, and the next int will return somewhere between 0 and all possible integers. 2 to the 32nd out there. So I don't want to do that. I want to use the bounds. So my bounds, I want to pick some random ticket between 0 and the number of entries. All right. So that's really what I want is, I don't need to pick between 1 and 10,000 to do any good. Between 1 and 20. That's the number of entries that are out there when it comes off and picks a ticket. Again, I'm still not checking for errors here. There could be 0 things inside of there. It's not necessarily a problem now, though, because I'm assuming that the user is going to add it in before they call a pick. Sometimes it's okay to code and just say, "Hey, user, if you screw up, it's on you. This is not supposed to." If every bit of code you write is foolproof against being broken, you're going to have a whole lot of error checking all over your code that's going to be redundant at some point. All right. So now, if I run this code again. Sorry, I moved this all the way down. Let me bring that back up. I'm adding in the entries 0 through 19, but when I pick the entries, you can see they come out in a very different order. So 11, 8, 5, whatever is coming along, they're coming out in a very, very different order than what they went in. So if I run it again, you see it's now 14 was the first ticket picked. And now if I run it again, 17 was the first ticket picked. So it is pretty randomized as far as that comes out. So that's much better. A random person is going to win our lottery inside of here. Now, this is for 20 tickets. Let's say, though, that I go through, instead of 20 tickets, let's go back to our raffle app and make it 200 tickets. Now, everything seemed to have run okay, right? Lots of tickets here, and it's pulling out all the tickets here, and it goes to 0. That's very good. But it brings up an interesting question on the data structure. So intentionally, I made the IDs be a little bit small because in the real world, you can't necessarily assume that everything's on the up and up. You have to kind of account for different errors. So let me show you something real quick. Let me do a quick search on the number 35. All right, so that one's okay. Let me see if I can find one here. Well, the point I'm getting at, I'm not finding them now because there's still a big range. Here, I tell you what, I can fix it quite easily. Let's change the max ID of this to be 4. It's because that's what my finger pressed. Let's do it again. So let's just say I only printed 4 tickets. So now I don't necessarily know the entry code, but when I pull the ticket, you can see there's lots of the same numbers inside of here. So in the world of raffle, what if somebody recognized the tickets that you bought? Like you didn't get them specially customized for your event. You just bought them from an open vendor. And they said, hey, those little red tickets, I have those. And so I'm going to go get my own tickets. I'm going to go submit them in. And for some reason, I mean, I don't think this is true. I think this is probably true. It's not like every ticket that's ever printed by those little tickets are unique IDs. They could be copies, or in a computer system, it's possible that two people enter the same ticket, a few seconds apart. So, or it's possible that the system has an error in it. The two tickets, end up getting added. So my ticket manager here is allowing tickets with the same ID to be added multiple times. And so we can see here, when I only have 4 IDs, there's a ton of tickets with 4 IDs inside of it. So I could solve this problem a number of ways, but really one of the best ways I can solve it is by changing the data structure. So when I'm picking a ticket, then I'm picking a ticket off of a list, which is fine, but the list doesn't assure that I have a unique set of tickets. So if I go up and I say ticket number 1, 2, 3, 4, 5, and two people walk up and say I have ticket 1, 2, 3, 4, 5. How do I sort out which one's which? Now the name hopefully would sort it out which one's which, because I have the name drawn on my ticket. But what if nobody put their name on it? What if they left it blank? So another option I could have in my ticket manager is, instead of using a list, I could instead choose a set. And so when I do a set instead, I could do, instead of an array list, I can't do an array list. There's a tree set and a hash set. I'm going to use a tree set here because that's the first thing that we'll be talking about in the class. As far as this example goes, it doesn't matter which one. The implementation of a tree versus a set is synonymous as far as the functionality goes. It's an implementation detail. It makes the algorithm more or less efficient one or the other. But the problem when I go to a set is there's no longer an order. A set does not have a remove feature of a number in the order. So I've got to change my code around here a little bit then. So I'm going to pause there for a second and leave it to you to consider, how do I pull something out of a set instead of a list, if I don't have the operation do it right away. So at this point, the two things you should be working on is implementing your random draw to make it truly random, and then starting to think about how you would do it for a set instead. Get started on that, think about it, and then start the next video when you are ready to get some information, or if you need help in figuring out how to deal with a set.